Hello, everyone. I'm Greg Weaver. Welcome to the Audio Analyst. Pardon me. Today, I want to talk about the relative values placed upon listening versus measuring. And it was spurred by a recent call from a longtime industry friend who needed to vent. It seemed that one of his social media postings had met with an excess of pushback and downright vitriol in the form of responses to some statements he had made about the values of subjective listening. It seemed that the responses came from a majority of remarkably narrow-minded, fixed-opinion members about the limits that are imposed by assuming everything can be measured. Now, the measurers insist that if it can't be measured, then it follows that it can't be heard. The vastness and diversity of our empirical evidence to the contrary suggests that such a response is just plain foolishness. Clearly, as the saying goes, the absence of proof is not proof of absence. To suggest that we can accurately quantify every attribute of our music system's acoustical playback performance is, well, absurd. For the past 4 decades at least, I've been espousing the opinion that while measurements are important and can get us close to a desired target, the final arbiter has to be what we hear. Even Andrew Jones discusses this reality in his recent conversations here on the channel, saying that as yet there are no measurements that can in any way faithfully indicate how a speaker will sound in a given room. Period. I cannot tell you how many past and current designers of cables, electronics, and loudspeakers all understand this basic tenet. Starting in the early 1990s, in conversation and in print, I've continually advocated that everything makes a difference. Things as seemingly innocuous as how interconnect and loudspeaker cables are routed in a system, or by the effects caused when setting something on top of a piece of electronics or a speaker, which will impact resonances and mass loading. And while a good number of such side effects are demonstrable by measurement, there are many more that evade the ability to be quantified at all. How could that be? What could be preventing our ability to measure some of these sonic changes, ones that are clearly apparent to a trained ear? It could be as simple as that we don't know exactly which property or attribute to measure. It may be that we are unsure or unaware of which properties may need to be examined and considered as a group relationship to quantify these sonic changes. We may not even be aware of what attributes we should be measuring and analyzing. I suspect it's even possible that we do not have the degree of resolution that may be necessary to uncover and categorize some of these audible, but as of now, immeasurable differences. There is no way to be able to say with any certainty. Honestly, my personal feeling is that it is likely some combination of all of these, as well as possibly some others we haven't yet thought of. Both the physical process and mechanico-transduction that are used in mammals for hearing evolved a remarkably long time ago. Structures nearly identical to the modern human inner ear have been found in fossilized remains of dinosaurs that died 120 million years ago. As complex and refined as it is, I hope that everyone understands that the combined ear-brain mechanism is by far the most sophisticated sound processing system ever imagined, let alone constructed, and because of its sophistication and extensive development, is one that can readily differentiate things that we are still unable to measure. Further, the reality of the fact that we can hear what we measure, but we cannot always measure what we hear, should be more than just self-evident. In fact, I'd like to share just one example where the pursuit of better measurements alone had a somewhat disastrous result. My friend, the late John Ulrich, co-founder of Infinity Systems, along with Arnie Nudell and Carrie Christie in 1968, which was a direct result of John and Arnie having worked together at Litton Industries as design engineers starting in the early 1960s. John's accomplishments in the world of audio include the successful development of the servo-controlled subwoofer, a product that would evolve to become the Infinity Servostatic 1, and the creation of the first Class D audio amplifier in the world, which he called the Swamp, a sort of acronymic contraction of the words switching and amplifier, that yielded 250 watts per channel, running at a switching frequency of 500 kilohertz, and both were developed in the late 1960s. After leaving Infinity, he continued to advance the development of switching amplifiers and founded Spectron in 1978. His pulse width modulation switching amplifier, the Spectron 1KW, a 500 watt per channel stereo behemoth, was extremely well received by the audiophile community at its introduction in 1992. And over time, it evolved first into the Spectron Musician, then with some significant improvement, the remarkable Musician 2 in 2003. Now, I'm sharing all this in hopes of making it clear that John was not just some garden variety audio designer, someone who got lucky with a product or two. He was, in fact, a highly educated, extremely accomplished, careful, and methodical engineer. So it was at about the same time that I selected the Musician 2 as my reference amplifier that he confided in me that he had spent a considerable period of time designing, improving, refining, and honing a line stage in work that had been done over many, many months. Now, he was so pleased with the measured specifications of this device that he stated that it measured nearly perfectly under every test he could run on it. Now, my first question to him was, why hadn't I heard it yet? At that question, he shook his head, and with a look of frustration and disappointment, looking like an errant schoolchild, he glanced down at his shoes and absent-mindedly kicked at the floor. He told me that despite its measurable perfection, everyone, every single person he had let listen to it had hated it. To the man, they had told him that it sounded horrible. It may have been a perfect test instrument, but it was inharmonious, amusical, and unlistenable to every industry person and musician that he had auditioned it for. Now, this is just one example of how measurements can be completely ineffectual at developing great-sounding audio gear. For another, just look at the industry-wide push to greatly reduce intermodulation distortion measurements in amplifiers in the 1970s. Now, the common approach was to apply global feedback to the circuit in varying methods and degrees. The assumption was that if the amplifier's measured distortion could be significantly decreased, then it must follow that it would sound better. And while designers and engineers were able to show vastly reduced overall measured distortions, the resultant music these amplifiers made was dull and lifeless, without body or verve. They had destroyed the musicality of the products they were trying to enhance, primarily because they had been measuring and attempting to fix the wrong things. Now, just as John Ulrich's ill-fated line stage demonstrates, the narrow focus of designing for measurements alone rarely produces any actual sonic improvements. Please know that I'm not suggesting that routinely advancing measurement methodologies and innovations aren't useful. They clearly are. What I am saying is that measurements are no substitute for listening, period. Another segment of the audio realm most often rebuked and summarily dismissed because of its seeming immeasurability, something that has become a veritable punching bag for the measurement cult, is equipment break run, or burn in. And while no one may have been able to measure it acoustically by taking in-room, in-play acoustic measurements, there is an overwhelmingly enormous body of empirical evidence supporting its veracity. When you look at it, several factors impact the reality of equipment break-in. Speakers seem to understandably make sense. Danny Ritchie of GR Research has posted a page at their website providing some supporting measurements for this audible effect in loudspeakers. I've included a link to that page in today's description. As mechanical devices, electrically driven pistons of one type or another, most typically dynamic, planar dynamic, or electrostatic, they are clearly more constricted and congested sounding right from the box. And if you've ever heard a new from the box electrostatic panel, one that has never had an audio signal applied yet, for the first few minutes, it sounds so bad that you'd swear it was defective. And there are subtler elements to speaker break-in too. Things like the components of the dividing network, with its capacitors, resistors, and inductors, as well as the hookup wire, forming and seasoning. Keep in mind there are mechanical changes here too over time, as these components repeatedly heat and expand, then cool and contract, as well as their electrical changes. But it seems easier to comprehend the relaxation of the mechanical suspension as the stiff, new, and never used spider and surround of a loudspeaker increasingly develop more flexibility, pliability, and linearity over time. One can clearly hear a loudspeaker open up, becoming more dynamic, especially in the micro realm, and offer more concise and precise imaging and sound staging cues over time. Typically, the most apparent and dramatic changes will occur within the first few hours. More and more subtle advances continue to be revealed over the next 100 to as many as 500 hours. Now, with electronics, while the vectors for break-in are understandably a bit different from those of loudspeakers, both the results and the timeline can be remarkably similar. When you power on any electronic component for the first time, an amplifier, a line stage, a preamplifier, a phono stage, a DAC, whatever, its sound will typically be somewhat harsh through the upper frequency regions and offer restricted dynamic range, and usually shows marked improvement within just the first few minutes. Now, while this change may not be as evident as that noted with loudspeakers, it is apparent. Typically, starting after 1 to 2 hours of playing time and lasting to some 3 or 4 days, you'll hear the power supply components forming and developing a comprehensive charge. Now, this should not be confused with the device reaching thermal stability, which will reoccur after every restart and typically is normalized within an hour or so. No, during this period, dynamic expression, sound staging, focus, and transience will make clear and desirable gains, and the sound stage will begin to open up and relax. This is a period when you may note that the component may take some Jekyll and Hyde swings in performance. For example, you may have deep, tuneful bass now, and then 15 minutes later, the low end may be lean and undefined. Such swings are not uncommon, and they will eventually settle out. Then usually, by about 2.5 weeks of uninterrupted play, frequencies from the upper mid-range through the uppermost treble limits will present with a smoothness and refinement, shedding most any remaining glare or grain they may have been exhibiting. And the lowest registers will offer better articulation, speed, and pitch definition. The result is superior resolution, elevated transparency, and a more even and natural timbral balance. Now, with some gear, these attributes will continue to show varying degrees of improvement up to the 1,000 hour of play mark, or roughly 6 weeks of continuous play. However, I should mention that a friend of mine who recently upgraded to some Uber tubed monoblocks stated that he noted a near revelatory change as they crossed about the 1,500 hour mark. Now, those of you who wish to dismiss all this as self-delusion or confirmation bias, please know that I and all of my similarly minded colleagues are well aware of and familiar with such concepts and understand that there is some validity to that concern. But the fact that we all hear the same things in approximately the same time period, in the same order, time and time again, over years of listening and decades, has taught us to accept the validity of firsthand experiential evidence over the lack of someone's ability to objectively measure it. And finally, I want to touch upon the subject of relativity and in two variations. First, it should come as no surprise that the better the equipment under examination, the more readily, likely, and pronounced such changes will be to notice and identify. Then, too, there is the individual experience level and acuity of the observer. So, in essence, attempting to identify these changes when listening to systems with poorer fidelity and deficient resolution, and/or assessments trying to be made by listeners who are unfamiliar or just less familiar with the revelations that can be experienced by gear representing state-of-the-art performance, will have a much harder time perceiving, recognizing, and acknowledging such audio cues. Now, I am in no way trying to disparage, look down upon, or invalidate the remarkable contributions made by great sounding gear at any price point. Seriously. I am suggesting that the greater the resolution and refinement of the system under evaluation, the more perceptible and apparent such fine and subtle shifts in performance will be. Period. In essence, I'm stating unequivocally that while we can hear most everything we can measure, at this point, with today's existing technology and methods, we simply cannot measure all the things we can hear. With some 50 years in and around this industry, having listened to thousands of unique and different products, the overwhelming and repeatable empirical evidence collected by my listening is considerably more compelling and relevant to me than someone's inability to verify by measurement what I and many of my friends and colleagues can hear without effort. Measurements give us a great jumping off point, but they are no substitute for listening. I want to thank all of my subscribers and suggest that if you find any merit or value in the information I'm sharing here, please subscribe. And don't forget to like and share links to your favorite episodes with your friends. Guys, I love hearing from you all, so be sure to leave your comments and questions. You may support the channel using Patreon, Venmo, or PayPal, or even by securing display advertising at the Audio Analyst website, and links for all options are provided in today's description section. As always, thank you for taking the time to drop by and visit today. Please be sure to stay safe and keep the music playing. Till next week, cheers.